All right, this is review two. Um, bunch of domain and range to start because I think we need it. So f of x is a natural log function. The domain is x is greater than 0. The range is all real numbers. G of x, x is greater than or equal to -4 because otherwise it's undefined. The -1 is a translation down 1 unit, so we have y is greater than or equal to -1. H of x is a polynomial, so it's all real numbers for domain. For range, you'd have to figure out the bottom value of the vertex of the parabola, which is going to be 0 in this situation, so it's y is greater than or equal to 0. Z of x is a polynomial, so it's all real numbers. It's also a line, and so I think about the shape of a line. That's got to hit every y value as well, so that's all real numbers. A of x is an exponential function, domain all real numbers. The -8 is a translation down 8 units, so it would be y is greater than 0. Sorry, y is greater than -8. Let me make that a little more clear. Okay, there we go. It goes down 8 units. There's a horizontal asymptote at -8. B of x is a sine function, which has domain all real numbers. The y values go between 1 and -1, inclusive. Don't worry too much about sine. There's a couple problems on here that you might need a calculator for, but it's not going to kill you. Don't worry. Number C, letter C. C of x is a log function. Domain is x is greater than -8 because the translation left 8 units in there. The range of all log functions is all real numbers. Domain of d of x is everything except for x equals 1 because that's the one value that makes the denominator undefined. This is a case 1 polynomial where the denominator has or rational function where the denominator has a greater degree than the numerator, which means that the range is y can't be 0. For the inverses, I think we should probably start with the domains and ranges so we can kind of just flip-flop all of them. The one caveat is this function, h of x, because h of x doesn't actually pass the horizontal line test, so we have to restrict part of it to be invertible. So we'll cut off half of the domain when we invert it, so then half of the range will be cut off as well of the inverse. So let's just rattle through the ones that we don't have to worry about, and then we'll talk about h of x in a little bit. So I'm just basically copying, except changing x's to y's and y's to x's from the previous problem. I am going to deal with h of x later, so we'll just kind of skip along. B of x is another one I got to deal with, but the domain is still okay. And then for the ranges, it's the old domains. Deal with that one later. This one should be all real numbers. A of x is all real numbers. B of x is not all real numbers. We'll deal with that one in a moment. This is y is greater than -8. And y is not equal to -1. Sorry, +1, my fault. Okay, so then let's do a little inverting. We're going to talk about h of x. I don't know. Let's do some inverting first. Okay. So I'm going to just kind of start by writing like x equals, x equals 2 ln y minus 9. We can kind of do that for a lot of them where we just flip the x's and y's and solve for x. Add 9, divide both sides by 2. I get x plus 9 over 2 equals ln y. And so then we get f inverse of x is equal to e to the x plus 9 all over 2. G of x is a square root function. We'll do x equals 1/2 square root of y plus 4 minus 1. We need to add 1 and then multiply both sides by 2, so we'll get 2x plus 2 equals root y plus 4. We got to square both sides, which gives me 4x squared plus 8x plus 4, I think, equals y plus 4. I get to subtract 4 from both sides. I get g inverse of x equals 4x squared plus 8x. Notice that the quadratic is restricted in its domain because of the original restrictions on the domain and range of the original problem. H of x, this is where we start to have to talk about some stuff here. So h of x looks like this, where we have a parabola, and this is at 4. You can complete the square or use the quadratic formula to find out that that crosses there. But really, what's important is that we're just using the right side half of the parabola. And so we're going to restrict the domain from the original problem to x is greater than 4, or equal to, which means that the new range will be y is greater than or equal to 4. That means also the original range was y is greater than 0, which means our domain is going to be x is greater than or equal to 0 here, because we're restricting that original domain. So let's invert it. By the way, h of x can be rewritten as x minus 4 quantity squared, which is going to be important for this one because when we invert it, we'll do that, x minus 4 squared. Remember that this is just factoring y minus 4, squared. This is just factoring. Take the square roots of both sides. We'll just use the positive one, so we'll just write root x equals y minus 4. So that gives us that h inverse of x is equal to square root of x plus 4. Alrighty, z of x is 3x minus 1. So we have to solve x equals 3y minus 1. So we add 1, divide both sides by 3. I get z inverse of x is equal to x plus 1 all divided by 3. Again, it's a line, domain all real numbers, range all real numbers. A of x is 2 to the y minus 3. Yep, minus 8. Okay, I'm doing this just like the rest of you. Okay, here we go. X plus 8 equals 2 to the y minus 3. We need to rewrite with log base 2 of x plus 8 equals y minus 3. So we end up with a inverse of x is equal to log base 2 of x plus 8, and then we just have to add 3 at the end. Alrighty. B of x is the interesting one. This is sort of, I said this in the paragraph at the beginning of the worksheet, but this is sort of like a pre-work thing for next unit. This is the graph of y equals sine of x. And you'll notice it doesn't pass the horizontal line test. So to invert it, what we do is we take the first sort of half of a period of the sine function and we invert that. And so we're going to use just the first from negative, this is like negative pi over 2, and this is pi over 2 for x values of the original function, which means that the domain of the original function gives us the range of the new function. So our new range is going to be from negative pi over 2 to y less than or equal to pi over 2. Oh, these should be or equal to's as well. My fault. Okay, so now we just have to invert it, but this is not a very exciting one because if you just write x equals sine of y, to invert, we just have to literally write b inverse of x is equal to sine inverse of x. I know, it's not very exciting, but that's what we do. You didn't really need to know that. You definitely don't need to know that for the test. It's just wanted to throw something interesting onto here. Okay, c of x is log base 2 of 8. Excuse me. C of x is this same function. So since c of x is the inverse of a of x, we can conclude that a of x is the inverse of c of x. So I'm literally just going to write a of x here. That's going to come to be important on the next screen as well. Okay. d of x, x equals 1 over y plus minus 1. To solve this for y, we can multiply both sides by y minus 1, divide both sides by x. We're going to end up with y minus 1 equals 1 over x, and then y equals 1 over x plus 1. So we get that d inverse of x is equal to 1 over x plus 1. Sorry, I'm speeding through. I just am trying to make the video not too long. There's our inverses right there. Okay, same function still. We have to do some compositions on this one. Just remember the idea of like the domain can't get less restrictive, it can only get more restrictive, and so it's going to kind of be a little bit interesting in some places. So here we go. H composed with z. I'm going to put z into h of x, so that would be anytime I see a 3x minus x, I'm going to write a 3x minus 1. This is going to simplify like that. I foiled. Make sure you're remembering your b terms when you're foiling out. Then we just have to combine like terms, so we get 9x squared. Negative 6x minus 24x is minus 30x. 1 plus 8 is 9, plus another 16 is 25. So there's our new function. Because the domain of both original functions is all real numbers, we're going to keep it as all real numbers. I would check my graph to make sure that I know what that looks like. Again, it's a parabola, but the range is a little interesting because it seems like the 3x minus 1 could potentially be moving it left, right, up, or down, and I'm not all the way sure yet, so I'm going to check that in my calculator actually. And it turns out that the range doesn't actually change. It's still the same as the original function h of x, so y is greater than or equal to 0 is our range. Okay, a composed with c of x, so I'm putting c of x into a of x. So here we go. C of x is log base 2 of x plus 8 plus 3, but I'm putting that into a of x, so it's like 2 to the all of that minus 3, right? Minus 8. Thing is, when you simplify all this stuff, you're going to end up with just x because these two functions are inverses of one another. The thing about this one, though, is it's that domain question where because the domain is as restrictive as the original function is, you still have to conclude that x is greater than or equal to negative 8, not equal to, greater than negative 8, because you can't ever put a negative 8 into the original function. So we couldn't do it in the composition either. You'll find that the range is also greater than negative 8 because if the function is evaluated at this spot, we would put it in here, and we would find out that we get negative 8 out, but because there's a not equal to there, we still have to keep it as a greater than. Okay, so that's that. Z composed with G, or zog. Okay, I need to do 3x plus minus 1, but I'm putting g of x in there. So I've got to put in my 1/2 root x plus 4 minus 1. The only nice things to do to simplify this at all is we could probably do the 3 times the 1/2, so we could write 3/2, and then we'll write root x plus 4, and then the only thing that we can do there left is just minus 1. Oh, I'm so sorry, I made a mistake because I had to distribute this 3 through here, so then I would get a minus 3, and then a minus 1 more is minus 4. So that's my fault. There's my answer. Okay, what's the domain here? Well, the domain of the inside function is still x is greater than or equal to negative 4, so we have to keep it like that. I probably need to check my graph to see what's happening with the range, though. And the minus 4 is making sense because it's all the way down at negative 4. The minus 4 right here is a translation down for it. That's what I'm trying to say, is that makes sense. Okay, decomposed with itself of x. We already know that they're not inverses of one another, so we do actually have to do that same thing. Okay, so 1 over x minus 1, but the x is now 1 over x minus 1. So that gets a little funky. What I do know already is that this interior stuff right here has domain x cannot be 1. So I know that's part of it, but there's other stuff that it can't be as well now because there's more rules. So the next thing I probably should do is try to simplify this a little bit. This is maybe a little bit beyond the scope of what's on the test, but it's just kind of interesting anyway. 1 over, I'm going to create a common denominator by making another, I'm multiplying this whole thing by x minus 1 over x minus 1. Just the 1 is what I'm multiplying by, because that's not changing the value, but it is creating a common denominator, so that now I can rewrite this as 1 over 1 minus quantity x minus 1 over x minus 1. I know this is starting to seem like, what are you talking about, Mr. Nelson? But it's a real thing. Again, not super critical for you to know all the details here. This is going to be 1 over, well, 1 minus negative 1 is 2, so 2 minus x over x minus 1. And now we know that when we divide by a fraction, that's like multiplying by the reciprocal. So this is just going to give me x minus 1 over 2 minus x. And this is how I'm going to write my final answer. However, it's kind of helpful for us to see this right here to talk about the domain. So the issue with the domain here is that the denominator can't be 0. And so you have to think about what could potentially make the whole denominator 0. Well, it's what would make 1 minus x, 1 over x minus 1, that couldn't be 1. Because otherwise, if I was subtracting by 1, then I would be making it equal to 0. So I have to multiply both sides by x minus 1. And I find out that x cannot be 2 either. And that actually makes really a good amount of sense here, because that's the spot that I got to where it says if I put 2 in there, it can't be defined either. So that works out really nice. X also can't be 2. So there's 2 domain restrictions. If we look at the original, well, the final composition, I can see that that's a case 2 rational function, which is where they have the same degree, and then we divide the leading coefficients of the x terms, and so we're going to get that y can't be negative 1. I would say, though, that there probably is a value that I'm going to get out if I put in this. And so, because I know that I can't put 1 in, so I can't get out whatever I get when I put 1 in. Do you know what I'm saying? So if I put 1 in here, then I get 1 minus 1 is 0, and then 2 minus 1 is 1, so I get 0 over 1, so y also can't be 0 in this situation. Again, this problem is a little bit on the hard side. I would maybe not worry a whole ton about this problem for our review purposes. Okay, f of z of x is our last composition to make. This one's really quick because all I got to do is I got to plop that linear function into 2 natural log of 3x minus 1. And then I think there's like a plus 9 or a minus 9. Yeah, minus 9. Like this. The restriction is that this thing in here has to be positive, so 3x minus 1 has to be greater than 0. So I get that x is greater than 1/3 is my x value for the domain. The range for any natural log function is always all real numbers, so we're going to keep it like that. So those are my domains and ranges for the first section. I got to do the evaluating with these on the bottom. I'm going to go steal the functions so that I can pull them to the bottom of the screen so we can actually work with them in a second. Okay, here we go. So I need to do b of pi over 4. This is a sine function. There's only 2 instances where I use b of x. I'm going to just give you the answers. B of pi over 4 is just root 2 over 2. C of 8, I'm putting it in for C of 8. 8 plus 8 is 16. Log base 2 of 8 is 4. I'm sorry, log base 2 of 16 is 4. 4 plus 3 is 7. d of 1 is undefined, because if I put it in here, I will get something undefined, divided by 0. F of e to the third. 2 ln of e to the third minus 9. What power of e gives me e to the third? Well, it must be 3. So 3 times 2 is 6. 6 minus 9 is negative 3. Gob. Okay, this time I'm putting in pi over 2 into sine of x. The sine of pi over 2 is 1. So I'm doing g of 1, really. So I'm putting 1 in here, and I get root 5 all over 2 minus 1. I would keep it like that if I were you. Okay, h of 4. h of 4 is 0. So a of 0 is 2 to the negative 3 minus 8. 2 to the negative 3 is negative 1/8. So you could write like 1/8 minus 8. That'd be fine. I don't know. That's not particularly nice looking either. Negative 7 and 7/8 is another way. Okay. Sorry, I'm rambling. Zod. Z of d composed with 2. So I got to do d of negative 2. Where is d of negative 2? D of negative 2 is 1 over negative 3, so negative 1/3. Then I'm putting that in here, and I get negative 1 minus 1 more is negative 2. F of e. F of e is 2 times 1 minus 9. So 2 minus 9 is negative 7. So I got to do c of negative 7. C of negative 7 is going here. Okay, so log base 2 of negative 7 plus 8. Well, negative 7 plus 8 is 1. Log base 2 of 1 is 0. 0 plus 3 is 3. G of negative 5 is undefined, because I can't put a negative number in here. I can't put negative 5 in there, because then I'll get square root of negative 1. That's undefined in the real numbers, so that doesn't work. Okay, z of 2 is 6 minus 1 is 5. And then a of 5 would be 2 to the 5 minus 3 minus 8. 2 to the 2 is 4. So 4 minus 8 is negative 4. Missed an equals sign on that one. Okay, A and C are inverses of one another. So as long as the input is in the domain of both functions, I'm good, because the input into a function, into its inverse, will give us that input back. So I don't even have to do any calculation here, because I know they're inverses of one another. Okay, h composed with h of 1. Who wrote these problems? Okay, h of 1. 1 squared is 1. 1 minus 8 is negative 7. Negative 7 plus 16 is 9. Now I need to do h of 9. So I've got to take my 9 and put that in. So I get 9 squared minus 8 times 9 plus 16. I get 81 minus 72 plus 16. I get 9 plus 16 is 25. There they are. Okay, I'm going to zoom out so you can see all the answers for the third page. All right, that is it. That's the end of video 2. I'll see you back for the next one. Like and subscribe.